Alright, hey everybody. Today we're talking about ellipses. These are oval shapes, so very similar to circles, except they're not symmetric all the way around, so they're ovals. And they do have a lot of similarities between circles and them. And so what I'm going to give you a second here to do is copy down the definition of an ellipse. The definition is not going to make much sense, but we're going to talk about it in class tomorrow, and I'm going to give you kind of a visual representation of how an ellipse is actually formed based on this definition. So hold tight, just get it copied down. By the way, the word that I underlined in red is foci, and it's actually the plural of focus. So you know what a focus is from like a parabola? So same kind of thing, you can imagine an ellipse as two parabolas that actually come together, and so they do have two foci, which is the plural of focus. All right? So one thing that's really similar between the equation of an ellipse and the equation of a circle is the center. So the center is still the h comma k. Same thing as up here. One major difference here is that the equation is actually equal to 1, and it's always going to be equal to 1. That's what makes it an ellipse. And so if you remember, the circle equation is actually equal to the radius squared. But we actually don't have a radius for an ellipse because it goes left and right a different number than it goes up and down, and that's what forms the oval shape. So it's really important to understand that. The standard form equation is always equal to 1 for an ellipse. And actually the a and the b help us determine how far up and down and left and right to go from the center. Okay, so the length of the major axis is going to be 2a, and the length of the minor axis is 2b. And you notice that in the equation of the ellipse, we have an a squared and a b squared underneath for those fractions. And I'll have you just copy down, remember that the major axis is always the bigger one. That's why it's called a major axis. The minor axis is always the smaller one. That's why it's called a minor axis. Okay, so that's kind of like obvious, kind of self-explanatory. And how to find C, which is actually going to help us figure out where our focus points are, or the foci, is we're going to use the equation a squared minus b squared equals c squared. Okay, so that's really similar to the Pythagorean Theorem. Notice that for an ellipse we have a plus in the equation, but there's a minus in the a squared minus b squared equals c squared. So just keep that in mind that it's actually opposites. And I'm going to tie that back in when we do our last conic, which is hyperbolas. And so the foci, or the plural of focus, like I said earlier, what that is 2 points that are c units from the center along the major axis. So I'm actually going to zoom in. And what this is there's two things. 2 points, c units from center, and they're always on the major axis. Okay, so two kind of pretty important things there involving the focus. So what you've noticed is that for this whole chapter we've kind of filled in these charts that don't really make that much sense so far. But you just kind of fill it in and it's there in case you get confused when you're doing a couple like example problems or whatever. So once we do that example there on the right, it'll make more sense as far as where I'm getting all these weird formulas and stuff from and what they're used for. So I do have a couple other notes for you. Just note that, number one, the A is the larger number, so that's always the major axis. That's what I wrote kind of above. Let's see. If the x radius, or the number underneath the x part of the center, is bigger, then it's a horizontal parabola, or ellipse, excuse me. And then similarly, if the y radius is bigger, that makes it vertical. And I'm putting radius in quotation marks just because it's not really a radius, but it's the same type of graphing thing that we did for circles when we use the radius up, down, left, and right. So if the y radius is bigger, then it's a vertical ellipse, meaning it's longer than it is fat, I guess. Kind of a weird way to say it. So now that we've got all those, like, I don't know, pointers filled in, let's zoom over here to this first practice problem. It's actually very, very simple to graph an ellipse. So what I'm going to do is I'm going to start with my center. It's going to be positive 2, comma, negative 1, and that's just h, comma, k, exactly like it is for a circle. So when I go to positive 2, negative 1, I'm going to put a dot right here. And then here's the important part. First of all, underneath the x value is a 4, and I'm going to square root that. And since it's with the x, that means I'm going to go left and right 2 units. And I got the 2 because I square rooted the 4. So just like a circle, I'm going left and right 2 units. And I'm going to put a dot there and a dot there. Okay, so same kind of thing with the 9. I'm going to square root that. And since that's with the y value, I'm going to go up and down 3 units, thus forming the elliptical shape. So it's not a perfect circle because you're not going up and down and left and right the same distance. So you can see that now it looks like an ellipse. So I'm just going to carefully try and kind of curve my sides here. Not really sides, not really edges. Parts of the ellipse. There we go. Okay, so that's how to graph an ellipse. It's actually very simple. Let's fill in a couple of these points here. We've got the center, which is 2, negative 1. Foci and C and all that, I'm going to skip that for just a second, but let's talk about how long the major axis is. Remember, the major axis is always the longer axis, so I'm going to actually do that in red here. Major axis is this distance right here from the two kind of endpoints of the major axis here. So how long is that red segment? It's 6 units. And if you notice that we went up and down 3, and that's where this 2a comes from, is because you had to go up 3 and left, or up 3 and down 3. That's where the 6 came from, or 2 times 3, which is 6. Minor axis, that's the smaller axis. I'm going to do that in blue. This part right here. How long is that segment? Well, it's 4. Remember, we went left 2 and right 2, so 2 times 2 is 4. That's where the 2b came from. So now only thing we have left to do is use that weird Pythagorean Theorem type of problem. A squared minus b squared equals c squared. And so what we're going to do is, I know that my a squared is always the bigger one, so that's 9. If you look up in the formula, looking right up there at the ellipse formula where it's a squared underneath the first part and b squared underneath the second part, well, the a and the b switch depending on which number is bigger. So the 9 is bigger than the 4 in my original problem here that I'm graphing. So that's why the 9 is the a squared and the 4 is the b squared. Otherwise, think about it, you guys, you'd have a negative number. So our foci can't be a negative number, distance, because distance can't be negative. Okay, so 9 minus 4 is c squared. That means that 5 equals c squared. That means that c equals plus or minus radical 5. So I just square rooted both sides there, and I used that Pythagorean Theorem type of formula to get that. So my c is plus or minus radical 5. And so if you actually think about like a decimal equivalent of plus or minus radical 5, it's about 2.2. So that means that from the center of my ellipse, so this is kind of the weird part, from the center of the ellipse, I'm starting on the center, and you have to know which one is the major axis, which is the longer one. So I'm going to go up and down, because the longer one is my major axis, 2.2 units. So it's going to be a decimal. So if I go up or down 2.2 units, it's about right here. And when I go down 2.2 units, it's about right here. Those are where my two foci are located. All right, and so now we just have to look at the graph and figure out what those two ordered pairs are called. All right, and it was a decimal equivalent, so can you tell me what the x value of the foci both are? Well, they're both 2, right? So 2 comma something. And how did we get the foci? Well, the y value started on -1, and then we added and subtracted radical 5. So I'm just going to leave it as -1 plus or minus radical 5. Just look at the graph. You don't have to like actually add the radical 5 with like as a decimal equivalent or whatever and give me 2 different points. When it's a radical like that, you can just leave it in radical form. So the y value was -1 plus radical 5 to get up to the top, and -1 minus radical 5 to get down to the bottom one. Okay, so it is a little bit confusing. You do need to like make note of a couple important things. The Pythagorean Theorem type of equation, that's what you're going to use to find the foci no matter what. And always keep in mind that the foci are located on the major axis always. So if this was a horizontal ellipse, then my foci would be located on the horizontal part. Okay, so it's kind of a lot of information. Let's just do one more example and see if you can get the hang of it, and then tomorrow in your groups you'll continue working on this stuff, okay? So the center for this next one is going to be 0, 3. So I'm going to go ahead and plot that point 0, 3 right up here. And then underneath the x squared I have 25. When you square root that, that means 5. And since it's with the x, that means left or right. So I'm going left and right 5. I'm putting points there. There's one here and one here. Okay, and then underneath the y is 9. When you square root 9, that's 3. So I'm actually going to go up and down, since that's with the y value, 3 units. So point right here, go ahead and connect. Okay, so let's talk about the major axis. I'm going to do the major axis in red, just like I did the earlier one. So the major axis actually is horizontal this time because it's always the bigger one. That's why it's called major. So the length of that is 10. That's 10 units. Or you know how we went left and right 5? Well, 2 times 5 is 10. That's why up in the chart we put 2a. The a is always the bigger number. And it's 2a because we went left and right 5. Anyways, minor axis. I'm going to highlight that one in blue. That's the smaller axis. And that was up 3 and down 3, so 2 times 3 is 6. Or you could just count by looking at the graph. Okay, now let's also talk about foci. So what we have to do is do a squared minus b squared equals c squared. Remember how for parabolas we memorize the formula 1 over 4p equals a, and we use that for every single one? Well, we're going to use this formula for all the elliptical problems. Okay, remember the a squared is the bigger one, so 25 minus 9 equals c squared. That means 16 equals c squared. So c equals plus or minus 4. So all that means, you guys, is that you have to start on the center, and your foci are going to be located plus or minus 4 units from the center, but always on the major axis. So my major axis here is the red one. So I'm going to start on the center, and I'm going to go to the right 4 units, 1, 2, 3, 4. And this actually ended up being a nice square root. I didn't have to approximate using a decimal. And I can actually figure out what those values are. So if it's not a decimal, if it's a whole number, you guys can actually give me 2 nice clean points. Okay, so those foci, again, we're just going to look at the graph. The c was plus or minus 4. And those 2 foci points, one of them was negative 4, 3. And the other one was positive 4, 3. Okay, so you just got to look at the graph, you guys. Let me talk really quickly about the difference between the first example and the second one. One of them is vertical, one of them is horizontal, and you can tell that by looking at the equations. If the bigger number is underneath the x value, that means it's going to be horizontal. If the bigger number is under the y value, like for example 1, that means it's going to be vertical. Remember that the foci are always located on the major axis. Okay, so that's what I'm going to write. That's what I have right up here. The foci are always on the major axis, so it's always on the longer run. And for this example, we left it in radical form just because I didn't want to have to do decimals. So I started, the y value was negative 1, I went up radical 5 and down radical 5. That's why I wrote the foci the way that I did. But in example number 2, that square root worked out evenly, so I could actually do 2 actual points. I guess you could leave it as plus or minus 4, 3 if you wanted to, but that's why we don't have a radical in there, because it's simplified evenly. Okay, whatever questions you have, bring them tomorrow. Otherwise, hopefully that wasn't too confusing, but we'll practice it in class tomorrow and I'll be able to answer your questions, and remind me to talk about the definition of an ellipse as well, because we'll do a little bit of a demonstration in class, okay? Have a good night. See you tomorrow.